Hello, everyone. Today we are going to discuss chapter 18 of the Mastering Shiny book, and it is on creating functions for the UI as well as for the server part of the app. So the learning objectives for today are to learn how to use functional programming in R to make many controls at once. That applies to the UI part, understand how to use those functions with reactives in the server part, and we'll walk through some of the use cases where functions could be really useful. So the first thing we are going to discuss is file organization. Functions allow you to spread your code across multiple files, which means that you don't have a very long app.r or shiny or server.r and UI.r files, which have everything in them. We instead create functions and then put them in a folder called R. So we have a directory R within our app directory, and we put everything there. This is similar to how packages in R are created, where you have to have an R folder which contains all the source code. So for example, if we create a function myfunc, that would go in its own file myfunc.r, and that would be stored in the R folder. If there are some common functions that you use throughout the app, those will be put in the utils.r file. And Shiny uses similar storing conventions, as I said, in our packages. So the first example here is where we are using one slider input and we're repeating it multiple times because we have multiple variables that we want to use in the app. In this case, we have 4, alpha, beta, gamma, and delta. And for each of them, we have different values for actually the same values for 4 options in slider input: min, max, value, and step. So those don't matter. We are just repeating them for different variables. So let's see that in action. I have this Posit Cloud project where we have this function slider input 0, 1. Before we use this function, we start with the example in the chapter where we have all the slider inputs provided as separate lines. And we have the regular Shiny app. Let's run that. You probably don't see my window that pops up. So I have another window that pops up which contains the result of the Shiny app. Do you see it?
No, we could still see your Posit Cloud.
Okay, I'm gonna launch this inside our studio. Let's try that. The viewer pane. Okay, so now we have the app here. If it's not showing up for you, let me know. So we have these 4 controls. In each case, we have minimum value is 0, maximum is 1, and we have the same selected value. So this is our end goal, but since we have multiple lines here, for each of them, we can reduce this code repetition by providing one line which acts as a function. So in this function slider input 01, we have the same parameters, argument values for the function, but the only thing that differs is the ID. So once we use that, I'm going to comment out this and comment in this simpler version of the app where we just reuse the slider input 01 function.
If I can ask a question about this,
Yeah.
for the new slider input 01 function, is it returning anything special Is it returning a function call? Is it even returning like HTML or CSS, anything like that?
It does because slider input itself returns CSS. We can take a look. So if I specify any value here in the console, and let's say the ID is simply ID, and the label is alpha. So in this case, the slider input itself produces this div, which has these tags, the label tag, and the range slider argument as a class. So the main tag that is used is input. And when we reuse this function, uh, running this in console, and if I run this for alpha, it will again generate a div, but now the ID will be alpha. So we have the ID here.
Okay, thank you very much.
You're welcome. So this was the first example. Switching back to the slides. Uh, the second example is where we have a different input, which is the week date input. And the book discusses that you could use different options here, like days of week are disabled for 0 and 6, which is used in the United States and generally in North America. But depending on the region, you may want to use something else. So there also using a function is very useful. If I comment out this now, go back to the US weekdate input. So here we have another function with input ID, and then we have the second dot 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 argument where we can provide more details about our date input function. So in this case, if we now look at the second example, I'm reusing that function twice with different IDs and different labels. Everything else, as we see here, is going to be the same. So we have the same format, date, month, year, and days of week are disabled. So running the app will now generate these two date inputs, which clicking on them, you'd get that this way. And if we look at the example here in the same way as we saw before for the slider input, that also an input tag, HTML tag that is generated within a div. And let's go back. So we've seen two examples so far where the functions and using the functions could really reduce the amount of coding that we do. This is another example where I really struggled to actually get an output. I read the book chapter and tried it many times, but I don't know how to use this function. We can give it a go again. So in this case, this function will generate radio buttons, and it uses the radio buttons function from mshiny, which requires an input ID, a label, choice names, and choice values. If you look at the radio buttons help, generally what we use is choices, but you can optionally also use choice names and choice values. We use these two, then we don't need to use choices. So choice names are useful when you want to show an icon instead of an actual text for the choice values. But behind the scenes, what you will process in your server will be the values. So in this case, they provide input ID, label, choices, and selected choice by default is null. And in this case, first using lapply, we have choices, and for each choice, it produces an icon. So I think the trouble I had so far was that the icon that I was providing was not was not correct for the radio buttons. So in this case, if you see the values line here, we have this if statement where we are checking if the choices are, if the names of the choices are null, then we provide names choices as the result, else we only provide the choices. So based on this and based on the icons that we provide, if I run this function first outside Shiny, this is the example that I tried, where the choices I'm providing, they are, I think, supposed to be from the icon function that Shiny uses. So check that in the help. So icon function requires a name for the icon, and the library it uses is font awesome. So I looked into the font awesome documentation and found some icons, and I provided them here. But whenever I try to produce this, I don't really get a good output. It's, I think, probably because these are not compatible with Shiny. But assuming that we provide the correct names here for the icons, then it should generate a radio button choice. So 3 choices where we have 3 icons. But behind the scenes, the values are used, which are check, times, and star. If there's anything you could help with, Derek, let me know.
Sorry, no, I don't have any further input.
Right. Maybe someone later would chime in. Okay, so moving on to the next point, using functional programming. So we've already seen one example where functional programming is used. So for this previous example, lapply is used, where it takes a list or vector of some values and then applies a function to each of those values. Similarly, we have the per package in tidyverse that also allow us to do the same thing using the map function. So in this case, this is example 18.2.1. So in this case, we are now switching to, we're still looking at the same problem of generating multiple slider inputs, but instead of creating that function and then using it this way, we are now going to even reduce the number of lines of code more by using functional programming. So now instead of using slider input 01 and then providing the ID and doing this 4 times, we create a vector of those 4 IDs. And then we create sliders, a list of sliders actually, by using the map function from the per package. We provide it with that vector of IDs, and we apply the slider input 01 function that will generate a list of sliders. And now we are ready to use that as our UI. Notice from the previous discussions of different chapters, especially for the UI, we have seen that we have either fluid page or some other kind of page as our main function, but that doesn't really matter. Fluid page and other page functions generally create containers in which we put all our inputs and outputs. But you can equally put a fluid row as the main UI that is also a container which will create a row. So that's why for the purpose of this demo, only fluid row is used because our focus is using functions. So if we run this example, we get the same result back. Now we have those 4 variables, 4 sliders in the same way, but it is more clear what we are doing here. Some may argue that This is more clear because this is a smaller example, but you could think of generating 10 or 15 different values and then repeating this 10 times looks more ugly compared to this, and it also less error prone if you use this approach. The next example regarding using function in UI is again building on the previous example. And this is again providing us flexibility to use multiple values or different values of multiple arguments in our sliders. So if we go back to the first example, we know that for the slider input, we have multiple parameters for which we can provide different arguments. In this example now, we are able to provide different values for each of these sliders. What we have seen so far is using the same default values for slider input, we have to manually provide min, max, value, or step if we want to make a difference between different sliders here. But we can do this with less amount of code and with less potential for errors if we use this approach where we first create a data frame with all the inputs for our input. So in this case, the input is slider, and the slider input uses multiple arguments. In this case, we are interested in providing 3 different arguments. ID obviously has to be different. You cannot use the same ID for 2 different inputs in Shiny. So we provide different IDs. We also provide different min values and max values for each of the sliders. And now we create a new function, which now does have some default values for min and max, but we can vary them if we want, depending on what values are coming from the vars data frame. So again, we use functional programming, but this time, since the input for our functional programming function pmap is not a vector or a list, it's a data frame, we need to use pmap instead of map. With pmap, when you provide data frame, it understands that I need to take one row at a time. So when we provide vars, it will take, for the very first entry, it will take this row and then apply the mySlider input function to it, which means it will use alpha as the ID, min value of 0 and max value of 1, and the others will remain, but default value is provided here. Again, for UI, we provide sliders in a fluid row. We run that, and we get this time different default values or initial values for the selected slider value. So this was everything about using functions in the UI part of the Shiny app. You can also think about other use cases, for example, to change the look of your app. Maybe you do not like the default left-handed or left-justified heading for your homepage. Maybe you want your heading to be in the middle of the app. So you can either use CSS or you can use the bootstrap classes to make them in the center of the page horizontally. And once you do that, you can convert it into a function. And for each page on your app, you can basically use that function to show the heading. Now let's discuss server functions. Before that, is there any question, Derek?
No questions at the time.
All right. For server functions, reducing the amount of code is also useful when we apply functions, but we also have other advantages when we use functions. So long reactives should be put into non-reactive functions outside the server. This is better because we do not want to do calculations in reactives which are triggered when we don't really need them to trigger. So it's better to push the non-reactive code outside of the reactives as much as we can. And it also makes it cleaner because we have less lines of code in our main app. And it's also easier to debug, easier to tell what inputs were passed to a function versus what was passed to the reactive expression if you find a bug in your reactive expression. So case one is reading the uploaded data. This is 18.3. So here we have the first version of that app. In this case, I slightly changed the app by using pslib, but doesn't matter because that's on the UI side. So in this case, we have a file input and we have three text outputs. And for each case, we are providing information about the file name, the size of the file, and the file type. Then we have a reactive which facilitates reading the file. So in this particular example, the only two valid file types are CSV and TSV. And then it shows the first few rows of the data that is read. So if I run this, right now we don't see anything, but we have this browse option. I guess I do have one example here. Let's see. So in this case, it does provide us with file name, file size, and file type, and also shows us the data. So this is the end goal for this app, but we see that we have in our reactive, we have this information about the app. We switch back to slides. This is the initial app that we have. And if we use a function instead, what it does is it takes a name and path to the file, and then it applies the same logic to read the CSV or the TSV file. But now we don't have that in inside the reactive expression. So in the previous example, we did have that inside the reactive expression. Here we have the reading part inside the reactive expression. But in this example, we have moved it so that we are using the function instead of providing all the code here for reading the file. That also means that if we do see a bug, it's easier for us to understand if that bug happened before this function was used, or if it was something inside the function that was wrong. So we can then go back, and if it was related to the function, we can just fix the function. If it was before the function, then we'll know, and it would be easy to debug. So if we look at that same example again, this time we have the load file function here, and let me run this app. I'm gonna browse. And we get the same result, but we have less code inside our main app, and we have separated the load file function. I put this comment here to emphasize that although in this demo, I'm using this function in the same R file, but it's better to put this inside an R folder, which is also in the app folder. This way, we don't have a lot of lines of code in the same file. And the final section for today regarding using functions in the server are internal functions. Sometimes we have multiple things that we want to repeat in the server part of the app, but we cannot really put those functions in the R folder because if we do that, they are unusable. For example, in this case, we have update tab set panel, which will eventually switch the page. So in this example, we have multiple tabs for the same app, and uh, we can select any of those pages. So each tab has this prefix page underscore. So let's say we have 3 pages. So if we select one of them, then it will update, and that what is not shown here is the UI part. So you can imagine it could be an action button. If you click on it, it will run this code, update tab set panel. So if you use this directly, you have to repeat this multiple times for each page. So if you click on this button, then it will update a tab set panel and it will go to that part. If you click on another button, then it will update a tab set panel again and it will switch to another tab. So that means you will have to repeat this line multiple times, depending on how many pages you have. But with switch page function, the code is now reduced, and we provide the switch page function right here, given the input, for example, an action button. As we will see in the next chapter, these internal functions are also useful when we are using modules. Modules are different from functions in the sense that they not only are applied to just one part like UI or server, they are made for both. So we have one module for the app that has a UI part and a server part, as we'll discuss later. But if you have the same module that you want to repeat in your app, there also you will have to then create an internal function that you will have to write inside the server part. You cannot separate it and put it inside the R folder. So yeah, this is everything for today.
Okay, thank you, Umair.
Thank you. So next week we'll discuss modules, and I'm gonna stop it.